A smooth golf ball sounds like it should fly better. Smooth things look fast. A polished surface seems as if it should cut through the air with less resistance. But golf balls teach the opposite lesson. A modern golf ball is covered with hundreds of tiny dimples. These pits are not decoration, and they are not there for grip. They help the ball fly much farther than a smooth ball. To understand why, we need to look at the air behind the ball. When any object moves through air, it pushes air aside. The air flows around the object and then tries to come back together behind it. But if the flow separates too early, a large disturbed region forms behind the object. This disturbed region is called a wake. A large wake creates drag. Drag is not just air rubbing against the surface. For a ball, much of the drag comes from pressure difference. The air pressure in front of the ball is relatively high. The pressure in the wake behind the ball is lower. That imbalance pulls the ball backward and slows it down. A perfectly smooth ball seems efficient, but its airflow can separate from the surface relatively early. Once the air separates, it leaves a large wake. The ball loses speed quickly. Dimples change the boundary layer. The boundary layer is the thin layer of air right next to the surface of the ball. On a smooth ball, this layer may remain smooth or laminar for a while, but it does not have enough energy to stay attached around the curved back of the ball. It separates early. The dimples disturb the air near the surface and make the boundary layer turbulent. Turbulent flow sounds bad, but in this case it is useful. A turbulent boundary layer mixes faster-moving air into the region near the surface. That gives the near-surface air more energy, so it can follow the curve of the ball longer before separating. Later, separation means a smaller wake. A smaller wake means less pressure drag. Less drag means the ball keeps more speed and travels farther. This is one of the strange lessons of fluid mechanics. Smooth is not always best. Sometimes a controlled roughness is better than a polished surface. The history is also interesting. Early golf balls were smoother, but players noticed that older balls with scratches, cuts, and wear sometimes flew better than new ones. What began as accidental damage eventually became intentional design. Engineers learned to shape dimples by size, depth, number, and pattern. Dimples do not create energy. The golfer and club provide the energy. The dimples help the ball waste less of that energy-fighting air resistance. Spin also matters. A spinning golf ball can create lift through the Magnus effect because the air moves differently over different sides of the ball. Dimples help make that aerodynamic behavior more stable and useful. So a golf ball is not just a small white object. It is a carefully engineered aerodynamic surface. Those tiny pits are not flaws. They are the reason the ball flies so far.